The simple disposable glove is a ubiquitous item in healthcare, labs, and homes, but few people know the complex, highly automated journey it takes from a liquid polymer to a protective barrier on your hand. This is the fascinating step-by-step process of how gloves are made inside a factory. Step 1. Mold preparation, the clean slate. The foundation of every glove is a ceramic hand-shaped mold, or former. Washing. The formers must be absolutely spotless. They are first washed thoroughly in a soapy or acidic bath, followed by a hot water rinse. This removes every trace of old residue, as even a speck of contamination could cause a weak spot or hole in the new glove. Drying. The formers are sent through an oven to ensure they are completely dry before the next step. Step 2. Coagulant dipping, the sticky layer. The clean, dry formers are plunged into a special chemical solution known as the coagulant. The purpose: this solution, typically made of calcium nitrate and calcium carbonate, acts like a magnet. When the former is dipped into the liquid latex or nitrile, the coagulant causes the rubber particles to instantly stick to the mold and form an even, wet gel film. Drying. A quick trip through a dryer is needed to set the coagulant before the main dip. Step 3. Material dipping. Forming the glove. This is the critical step where the glove is formed. The dip. The formers plunge into a large tank containing the main compound, natural rubber latex or synthetic nitrile in neoprene liquid. Thickness control. The duration of the dip and the speed at which the former is withdrawn are meticulously controlled to ensure the glove achieves the precise, required thickness. Step 4. Leaching and washing. Purification. The wet gel glove film must be purified before it is cured. Leaching. The formers are passed through tanks of warm, circulating water. This process, called leaching, washes away residual chemicals and water-soluble proteins, especially important for reducing allergens in latex gloves. Beading, cuff rolling. Automated brushes or rollers tuck the wet gel edge at the wrist into a neat rolled cuff, the bead. This cuff is essential later for easy donning and prevents the material from tearing. Step 5. Vulcanization and curing. Baking for strength. The gloves are still a weak, wet film. They need to be baked to gain strength and elasticity. Curing. The formers travel through a long, hot oven. The heat triggers a chemical reaction, vulcanization, which creates cross-links within the polymer structure. This turns the soft, weak rubber into the strong, flexible, tear-resistant glove we know. Step 6. Coating or chlorination, easy on, easy off. To prevent the finished gloves from sticking together and to make them easier to put on, donning, they undergo a final surface treatment. Chlorination. The gloves are exposed to a chlorine acid mixture or chlorine gas. This hardens the surface and makes it slicker. Polymer coating. Alternatively, the gloves may be dipped in a thin layer of synthetic polymer, which acts as an inner lubricant. Step 7. Stripping and packaging. The grand finale. The gloves are now complete, cured, and ready to be removed. Stripping. For natural latex, a burst of compressed air often peels the glove right off the former. For stickier nitrile, workers may manually peel the gloves off the molds. Inspection. Every batch is subjected to rigorous quality control. QC tests. This includes inflating gloves to check for holes, filling samples with water to ensure they are watertight, and measuring tensile strength. Packaging. Once approved, the gloves are counted, stacked, and packed into dispenser boxes, ready for distribution around the world.